Okay, everybody. So we're going to go ahead and get started here. Let me get a display capture working. There we go. Okay. So what we're going to be doing today is we're going to be doing a little bit more on homework 4. I think that we're going to get to the point where we know how to finish it. Let me move this out of the way. Okay. So yeah, so let's go ahead and see where we were and pick up from wherever we left off here. So, whoa, let's go Octave. And do I have a text editor? I do not. Yeah, Notepad. Is that what I use? No, let's use Programmers Notepad. What do I type in? Notepad plus plus? Yeah, go Notepad plus plus. Whoa. Okay. So, yeah, I think this is what we were writing last time. All right, so let's go ahead and look at where we are. So actually, let's get rid of this. All right, so if we look at what the first thing we had to do was for this programming assignment, programming 4, the first thing we needed to do was we needed to make sure that the function player move .m needs to work. You change one line, and then it will, and we can run player test.m, which is a script to test it. So we did this last time. We can verify it here. Last time I used MATLAB. This time I'm going to use Octave. So let's type player test. I'm in the right folder. There's player test. And what player test did was you just pick like a number for the move, and it will put a 1 in that spot. So if I pick 9, spot 9's down here. We can go upper, like what's the middle? The middle's 5, like that. It's not checking for wins. We're not playing a game. It's just making sure you can fill in all of the spots. So we did 1, 5, 9. We can do spot 2, which is right here. Remember the way the numbering worked? It's 1, 2, 3 going down, then 4, 5, 6, 7, 8, 9 going down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all this function does is if I go through and I type all the numbers 1 through 9, it will just fill out this. And when the whole table is filled out, it'll stop, which is why we're back at the command prompt here. So we did that. All right. After you do that, then what you need to do is you need to make the tic-tac-toe game functional. And it's not functional when you start because it doesn't know how to check um, all of the game over conditions. So you need to change check game over needs to be modified as well. There are 8 ways to win. 8 ways to win. Now, what are the ways to win? Remember, it's 3 in a row, vertically, horizontally, or diagonally, right? And so, right, something like this. Hold on. Right, something like this would need to be detected, and player 2 should win this, right? Because they got 3 in a row. Um, so you get the horizontal right there. Um, Vertical, of course, you can win with 3 in a row vertical. So like 1, 0, 2. I'm gonna make player 2 win again. I don't know why. Right, like that. I guess it couldn't be that because player one should have more moves, but like, so you need any of the vertical or horizontal ways to win. So horizontal, vertical, and of course, diagonal as well is winning condition. So let's make player one win this one for some reason. Right? So diagonal. So there's 3 horizontal rows. So you need to check for those 3 winning conditions. 3 vertical rows. So you need to check for those 3 winning conditions. And then there's 2 diagonal, like the diagonal that goes down left, and then the diagonal that goes up and to the right. So this one and this one. Okay. Now, what it comes down to for each of these is that you need to know which positions need to match. So, like for horizontal, the winning conditions are going to be like the top row here. This entry right here is entry 1. This entry right here is entry 4. And this entry right here is entry 7, right? Because of the way the numbering is. So, like this whole row here is entries 1, 4, and 7, right? So the 3 ways you can win are 1, 4, and 7 need to match. Or another way to win would be if the second row matches, and which entries are those, right? Remember that the board numbered like this: 1, 4, 7, 2, 5, 8, 3, 6, 9, right? So 1, 4, 7 is the top row. The second row is 2, 5, 8, and then 3, 6, 9. So 2, 5, 8, or 3, 6, 9. So those are the entries for that would have to match in order for a horizontal row to be, a win. So if we look in CPU, check game over, hopefully we did some of these. And we did, although we did the vertical ones first here. So I think we only added one of these. So when it started out, I think I did these 2, and then we added this one. So for the vertical, you're looking at entries. Well, the first column is 1, 2, 3. The second column, right, 4, 5, 6. And the third column is 7, 8, 9, right? And so if you look here, that's what we're doing with this type of line. So what we're doing is we're checking that if we're doing 1, 4, 7, then, or sorry, we're doing 1, 2, 3 here. If you're doing 1, 2, 3, the first column, then the first thing we do is you check that they're not 0, because 0, 0, 0 is not a win, right? 0, 0, 0 is empty. So we check one entry to make sure that it's non-zero. And then if it is non-zero, then what we do is we're going to check if the 3 entries match. And there's no way to say, like, we don't have a function that says, do these 3 things match? We could have written a function that would have made our life easier, but we didn't. And so in order to find if 3 things match, entries 1, 2, and 3, we say, does entry 1 equal entry 2? And then does entry 2 equal entry 3? So if 1 equals 2 and 2 equals 3, then 1, 2, and 3 are all equal. So they're all equal, and then the first condition is that they're not 0. So if they're equal and they're not 0, then somebody won. Now, we don't know who won, player 1 or player 2. And so we assign the game over to be board 1. And that way, board 1 is either a 1 or a 2. Whichever player is in that spot is actually the winner, because they're the one who has 3 in a row. Okay, so that's why we don't just say like game over equals 1 or something, because game over equals 1 would mean player 1 won. All right, so then you just do that 8 times. So we got entries 1, 2, and 3. Then we did 1, looks like, no, 4, 5, and 6 here. So 4, 5, and 6. We checked if 4 equals 5 and if 4 equals 6. That'll work. You could do 4 and 5 and then 5 and 6, or 4 and 5, 4 and 6. Doesn't matter as long as they all win. And then something you have to be careful to change is that, when you do this game over to find the winning player, you better make sure that this entry here, board 4, is actually a 4, 5, or a 6. If you leave it as 1, then this code will be broken, right? Because you're trying to find the player that won, and the player that won is in spots 4, 5, and 6, not 1, 2, and 3 anymore. So this checks 4, 5, and 6. Then this was, 7, 8, and 9 probably. And we can see that. So 7's non-zero, 7 equals 8, 8 equals 9, and then game over equals board 4. Oh, that's a mistake, right? This would be a mistake. This needs to be one of the entries that you see up here, 7, 8, or 9. Okay, so those were the 3 columns. Then you need your horizontal rows here. So the horizontal rows are 1, 4, 7, 2, 5, 8, 3, 6, 9. So the first one we did was 1, 4, 7, 7. So again, check that 1 is not equal to 0. 1 equals 4, 4 equals 7, and then game over equals spot 4. Could be, again, we could use a 1, we could use a 4, we could use a 7. It doesn't matter because we've already checked that those are all the same. So that's it. Okay, now you've got 2 more. You still have to do the 2, 5, 8, and you still got to do the 3, 6, 9, and then you need to do the 2 diagonal. That's not how you spell diagonal. Okay, 2 diagonal. So we still need the 2 diagonal spots, which I didn't even write, but you'd have to figure out what these entries are. What are they? 1, 5, 9, 1, 5, 9, and 3, 5, 7. But you can do those yourself. I'm not going to. All right. Now, once you add that, you're done. The rest of this code should be correct. And yeah, the rest of this code should be correct. So as I'm doing this, by the way, I'm kind of looking for, hopefully we're not like semicolons and stuff. I don't want there to be, I think there's a little bug in the code where it prints a board twice. Okay, so we did all that. So now what happens is at this point, tic-tac-toe works. So tic-tac-toe now works, but it's dumb, but the CPU is dumb. So we have to fix it. So the way this works is CPU move .m is a function. What it does is this. It makes CPU moves this way. So the first thing that it does, do like A. So the first thing that CPU move.m does is it calls CPU move smart .m to get a move. Now a move 1 through 9, right? Those are the spots. So it expects a number 1 through 9. But CPU move smart might return a -1. So either CPU move smart returns a move, a valid move, 1 through 9, or it returns 0. Oh, sorry, -1. Okay. If it's -1, that's invalid. Okay, so then if we have -1, so if the move is invalid, then you call CPU move dumb. Oh no, it's called random. CPU move random, which will generate. Come on now. Okay. Okay. Life is hard here. Hold on. Excuse me? Okay. All right. The move is invalid. Call CPU move random, which does what it says, which will return a valid move, but it's generated randomly. A random valid move 1 through 9. So basically, CPU move random is a fallback. So it tries to make a smart move, and if it fails, it makes a random move. That way, it always has a move. And that's why the code works if you just run it. If I just run tic-tac-toe, right, it says choose a valid move. So I pick, if I pick 3 for my move, why is it printing the board like this? I want to find that real quick. But if I pick spot 3 is here, and then the computer went to spot 2, and it says the CPU chose the smart move 5. So that was actually returned by CPU move smart. In fact, that's the only thing that the smart function does right now is take the middle spot, if it can. If the middle spot's open, it takes the middle spot, right? But after that, every move that I do here, like if I pick spot 3, I already picked spot 3. If I pick spot 2, then the computer just took a random move. You can see CPU chose random move. That's because the function CPU move smart did not return a valid move because we didn't tell it to. Basically, we haven't made CPU move smart yet. So this is how it's supposed to work. So we have to make it smart. So we need to add logic to CPU move smart to make the CPU better. What we need to do basically to make it play tic-tac-toe perfectly, or almost perfectly anyway, is you want to, if there's ever 2 in a row, you need to fill in the spot. Whenever either player has 2 in a row, the CPU should, fill that in. That's the easiest way to make it play tic-tac-toe pretty well. Now, the reason it's either player is because if the human opponent has 2 in a row, then the CPU needs to fill in the spot, right? Like if you have 1, 0, 1, and then 2, let's say like this is how it is, right? Like if this is the board, then the CPU would need to see that there's a 1, 0, 1 here and realize that they need to go right here in order to block the player from winning. Okay. But on the other hand, if the board is why not the arrow keys working? On the other hand, if the board is like this, where the situations are reversed here, if the CPU, which is player 2, has 2 in a row and the third one's empty, then the CPU would still want to go to the same spot because then the CPU can win. So basically, this logic here, whenever a player has 2 in a row, CPU should fill in the third spot. That will either win or block. Either way, it's something that you want to do. So you have one small piece of logic, and it will do a lot for making the CPU play better. So that's why we're going to do that. Now, the thing is that there's a lot of ways to have 2 in a row. Just think the top row here. The top row could be like 1, 1, 0, right? Or 1, 0, 1. That's another way to have 2 in a row. Or 0, 1, 1. So there's 3 different ways for that to be, well, there's 3 different ways for that to be 2 in a row, right? And so if you think about it, if there are 8 winning conditions from up here, 8 ways to win, and each way to win would have 2 in a row before it had 3 in a row, then there's actually going to be like 24 different ways to have like 2 in a row. So that's a lot of code. Now you can be smart. Like if you wanted to try to detect all of these in one line of code, you could, but it might be hard. So you could either do 24 different if statements basically in CPU Move Smart, or you can just be more clever and figure out a way to combine different cases. So let's look at that now. So we have CPU Move Smart. Okay, so here's what it does. So looking at this code, what it does is it says move equals -1. Remember, it turns a -1 if it doesn't have anything smart to do. Okay? And then I say I like the center spot, so take it if it's open. So that's just the first thing that it does because that's what I coded it to do. Take the center spot if it can. All right? So very simple logic. If spot 5 is open, right? Open is 0, then move to spot 5. All right, and that's all you do in this code. You just say move equals 5. You don't update the board in this code. You just specify a number 1 through 9. Okay. Now here's how we're going to block stuff, right? So what this says here is we've got 1 equals 3, and board 2 is 0. So what's that say? 1, 2, and 3. So that means the first column is either like this, 1, 0, 1. That's where spot 1 and spot 3 are equal. But then spot 2 is 0. So it's a 1, 0, 1, or it is a 2, 0, 2. It's one of those, right? So that's what this detects right here is this case. 1, 0, 1 or 2, 0, 2, because it's a spot 1, 2, 3. We're looking at the right-hand side, right? Like 1, 2, 3, one column at a time. So you do that. And so basically, if this is the situation, then you would want to, put your move to be move equals 2. So this is very similar to the code that you had in the check game over, but this time you're checking if 2 of them match and the third one is 0. All right. Now there's other clever ways to do this, by the way. Because we are using numbers here, yeah. Well, yeah, maybe not. There might be clever ways you could do this where you check multiple conditions in one go, but there might not. So it's just, hey, let's do this. So this one was like I said, the 1, 0, 1 case vertical. Well, that's only one of them, right? what about you still need 1, 1, 0 case, and also you need the 0, 1, 1 case. So there's actually 3 of these just for that first column. So do that. Now, how would I do this case? Well, if it's this case, then you're looking for board 1 should be not 0, right? Like that. Board 1 should equal board 3. No, if we're detecting this case, board 1 should equal board 2. And then board 2 should equal 0. No, the open spot is spot 3. So like that. And if that's the case, then the move would need to be third spot, because the third spot's open. Okay? And so you can do this. So this is going to be for column 1 here, basically. There's 2. And then the third case would be, which I just erased, we would want the first spot to be open, right? We're doing this case now. So the first spot should be open. Well, if the first spot is open, this is already wrong because it says the first spot should be 0. No, we would want the, I guess, second spot should be 0. Second spot should be 0. And then the second spot should equal the third spot. And then the first spot should be 0. And then we would want to go in the first spot. Okay, so all of that for column 1. And you just have to change those numbers around to do column 2 and column 3, right? So you got 3, so you have to do column 2 now. Right? And then after you're done with those, you have to do column 3. And then after those, you have to do column, no, there's no column. We're done with the columns. You'd have to do row 1. And then row 2. And then row 3. And then, there's a diagonal 1. And then there's a diagonal 2. And so every time you add more of these in, then you make the computer play a little bit better. So like let's add the top row. So what's the top row? So the top row would be like 1, 1, 0, right? That would be one of the things, or could be 1, 0, 1, or it could be 0, 1, 1. Right? That's what we're looking for. Or 2s, but you don't have to specify that. So it's just the same thing. You just take one of these blocks and say, okay, well, remember that the top row is 147, 147, 147. So in this case, if this was 1, 4, and 7 here, let me just remember they're 1, 4, 7. So what we would want for this first case would be if 1 is non-zero, which it is, and then 1 would have to equal 4, right? So these two are equal. And then the third spot would be 0, and the third spot is 7. So the third spot, 7, is 0. And in that case, we would want the move to be 7. Okay, so we save that. Let's save that. Let me look at my tic-tac-toe because there's somewhere where it's printing out the board where it should not. All right, semicolon, semicolon, semicolon. Semicolon, 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 semicolon. They're all semicolons, so it must be in display board. Let's look at display board. Semicolon. Okay, I think that'll do it. Okay, so we have some winning conditions now in move smart. We got one, so we have 1, 2, 3, 4, 5. 5 different smart moves now. We got all of column 1 and one of row 1. So let's stop this running and start a new game. Tic-tac-toe. And we're going to try to get a first column because I know that I coded all of that. So let's take spot 3. That still does it. Where is that board coming from? Game isn't over yet. And then it spits out the board. Maybe it's in the check game over. No. I want to fix that. Sorry, that's annoying me. So it says game isn't over yet and then displays it. But it's before it says CPU chose the smart move. So is it in CPU move? No, right? It's before it says CPU chose. So it's before this. So board move equals 2. There's a semicolon, move equals CPU move random. There's a semicolon. There's a semicolon. They all have semicolons. So is it coming from the raw tic-tac-toe? No, it can't be, right? What is responsible for displaying board equals? That must be when it puts the 2 into the board. So it should be CPU move smart should be CPU move that's doing this. Board move. Ah, there it is. I think it's right there. Okay. Close. I'm starting it over. All right, valid move. I'm going to pick spot 3 again. Okay, yeah, thank you. So it shows me my move, and then it shows me the computer move. Now it says CPU moved the smart move 5. That's because it took the middle spot because the middle spot was open. Now, we coded all of the logic for column 1. So if I take spot 1, the computer should take spot 2, right? So if I take spot 1, the computer will take spot 2, and it will tell me it was being smart. Right? So it did. So it put a 2 right there, and it said CPU chose the smart move. 2. So it blocked me from winning. Now, if I'm smart, I will block the computer from winning, right? So the computer should see 220 here in the middle row, but it doesn't. I'm going to leave that spot open just to see if it picks it. So I'm going to pick 4. Right? So here's what happened. I picked spot 4. And then the computer saw 1, 4. It saw that I had 1 and 4 picked, and then it knew to pick 7, right? So it actually picked this corner spot because it saw 2 in a row, so it picked here. It didn't see this 2 in a row because I didn't code that one yet. Now, one thing about this, by the way, is if you code it just the way that I said, then it has no priority, right? So like if you ever have a case where the board is like this, like if you ever have a case where the board goes 1, 1, 0, 2, 2, 0, and let's just say 1, 0, 0, something like this. I think that's actually what we did have, right? If it's the computer's move, if the computer picks this spot, it would win the middle row. If it picks the top spot, it will block me from winning, but it won't win. Okay. And the way that I'm coding up the CPU move smart is it doesn't differentiate between blocking and winning. And so if you really wanted to do that, you would kind of have to double up the work here. So instead of 24 conditions, it would be 48 conditions that you have to code. Or you just need to make the logic of these little if statements smarter. But yeah, it doesn't have to play perfectly. That's not the job. The job is just to make it play well. So this will still be fine. It won't necessarily see that it could have won, but that's okay. So the game continues on here. I'll pick spot 8. And they went somewhere. I don't know. And the only spot that's open is 9, so I'll pick 9. And it's a tie, right? Nobody got 3 in a row. And so there you go. I mean, that's how it goes. You can easily win if you, right now, if I just use like the third column because I didn't code up logic for the third column. So if I just go third column, I'll win. All right. Which, I mean, I'm a tic-tac-toe genius. So that's it pretty much. What you need to do is just any of the logic that you want, you code up in CPU move smart. Now, the way I did it was the simplest way, and it will make the computer play okay. If you have better ideas, feel free to use them. For example, this could have all been combined kind of into one statement if you were clever. But it would be, a little harder to write than this. Or if you use some index, right? Column 1, column 2, column 3, maybe you could have done some kind of like for, column equals 1 to 3, and then you could use a statement like this, but inside of your for loop. But then instead of actually hard coding numbers here, you could have used the column entry, right? So like this is 1, 2, 3, or 4, 5, 6, or 7, 8, 9. So this is actually, if I go 0 to 2, actually, if I number my columns 0, 1, 2, then it wouldn't be board 1, it would be board 1 plus whatever column we're in. Board 1 plus whatever column we're in. Board 3 plus whatever column we're in. There's one more hanging off the end, right? Oh no, it's right here. Board 2 plus whatever column we're in. And then the move would not be 2, it'd be 2 plus whatever column we're in. Why would that work? Well, think about it. What we're doing is, so let me just make this wider. So if you do it like this, a for loop here, then if column is 0, this is 1. 1 equals 3. And 2 is 0, then the move should be 2, right? But we're going to go through this 3 times. So the second time through here, column COL is going to be 1. In that case, this would be, actually, I got this wrong. This would be 1 plus the column. That would be 1 plus 2 would be 3. That's not what we're checking. This is 1, 2, 3. The next one would have been 4, 5, 6. So it would actually have to be 3 times the column. 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 I think that's right now. Because if you look at it, look at the numbers. So again, it's 1, 1 and 3, and then 2, and then 2 if column is 0, right? So all these numbers down here are 1, 2s, and 3s when call equals 0. When call equals 1, what are the numbers? This would be 1 plus 3, which is spot 4. So that's this spot, middle top. And then 1 plus 3 would be 4. That's the top spot again. And then 3 plus 3 times 1. 3 plus 3 is 6. That's spot 6, which is down here. And this last one, 2 plus 3 times call, would be 3 plus 2 is 5. So that'd be the middle spot is open. So you see, if you do it this way, then you're checking the entire first column, and then when COL is 1, you're checking the entire second column, and then when COL is 2, you're checking the entire third column. Now, you'd still have to do this 3 times here, but if you do this 3 blocks like this, would actually be taking the place of 9 of these, because one for loop takes care of all columns. So it's not these 3, it's this right here, code right here, would take the place of the first line here, the first line for column 2, and the first line for column 3, because it's doing columns 1, 2, and 3 separately. So you could do 3 of these blocks instead of 9 of these littler if statements. And that's how you can combine logic. Or you could just make a list of every entire winning condition somehow and store it in a vector and then make the computer go down the list. There's lots of ways to code this. What I wrote here was just kind of the easiest to understand way. Okay, so once you do that, the more you add, the smarter your code is, and what you want to turn in is just the code as good as you made it. So that's what it comes down to. So this is just telling me to do all this. This is telling me how to do all this. Game over. And and when you finish that, there's other stuff you could do. Like instead of displaying the boards like this, you could actually use X's and O's. You'd have to, figure out how to do like printfs to do that. You could do something else to get the player move. If you use MATLAB, you might be able, you could pop up a window to ask for player moves or something weird. And if you want to get really fancy, you could figure out how to draw a display board in a little window instead of just displaying it at the command prompt. But these are just ideas if you are bored. This is not required at all, any of this stuff. Okay, so that's programming 4. It will be due next Friday. Okay, next Friday into the day. I will have office hours all next week. I don't know what times yet, but you can turn this in whenever you can turn this in, or you can get help whenever you need help. All right, and that's pretty much it. So I will talk to you guys later.